I saw this tweet once saying FP does not worth it. It's very time consuming, hard to understand, hard to read, and I'm fine with some bugs caused by mutability and side effects. I was so happy to see it because it's such a great filter. Like other technologies and things in general, FP is not for everyone. When choosing a job or picking a community, values matter. It's vague and not explicit, but I know that I gravitate towards FP. Languages, concept, communities, and so on. I know that under this umbrella, I'm gonna find people and jobs that I can relate to, while working with others doesn't bring me any joy. And just to clarify, I'm not gonna be talking about some BS corporate values like loving your customer and transparency. I want to talk about actual things we care about.
And a disclaimer, I cannot speak for everyone. There is no one FP or no one FP community. My experience comes from various places, as I've been in the pod for a few years. FP conferences, online communities, and jobs. In Europe, the US, Haskell first, Scala first, and so on. So for the purpose of this topic of FP values, I'll cover the most common trends I've observed and experienced. Naively, we might say that all languages and communities care about performance, security, multi-platform support, and so on. Obviously, nobody wants to write not performant, insecure code, right? Well, it depends, because you can't have it all. For instance, there are operating systems that specifically focus on security and have to sacrifice performance, out-of-the-box experience, and some hardware compatibility, or all at once. On the contrary, what language comes to mind when you think about simplicity? Would it sacrifice performance and security to make things simple? Probably, because simplicity is their core value. So, what are the core FP values? I'll start with a personal favorite, curiosity, which I think is the coolest part of our job. There are so many different ways of doing things, so much to learn and explore. FP is even better in this regard. For instance, there is no standard way to organize an app or handle errors. Some might find it annoying. For me, it's the opposite. We're not stagnating. We're constantly trying to come up with better approaches. We don't want to settle on 23 design patterns and use them for everything for years. We don't have to do what everyone else does. We can find our own way. Languages and library developers are on the same page, constantly innovating. Both Scala and Haskell are at least partially research languages. Not everything sticks. Someone's curiosity and research paper is someone else's maintenance burden. But you don't know if you don't try. And there is another tiny problem here. The aha moments. What a joy! Most people, when they learn something, get a dopamine kick, which might lead to an addiction, which might lead to devs getting high in mathematics and failing to deliver. Also, we don't like null pointer exceptions, compiler preventable bugs, and waking up in the middle of the night. We prefer to write robust code. Note that even the core values are not equal. For example, some people value robustness less than curiosity, for example in research or academia, and some other way around. Robustness comes at a cost. In FP land, you cannot pretend that only the happy path exists. You have to deal with the unexpected. Optionality, like missing values, handle errors, be explicit about I/O, and so on. Other values aside, Haskell and Rust are quite beloved by blockchain and fintech startups. Using less error-prone language contributes to the reliability and robustness of the code we write. Additionally, FP devs accept more rigorous testing techniques and analysis, such as property-based testing and formal methods. And if it seems tedious, remember that mistakes in code can be expensive and harmful. At the same time, we write the code that we have to maintain tomorrow, next day, and next quarter. Because on top of what I mentioned, we don't like one-off scripts, boilerplate, poor types, because we prefer rich type systems, and invariants outside of the code, somewhere in the comments or developers' heads. Robustness and maintainability come hand in hand. The more robust the code is today, the easier it is to maintain it tomorrow. Maintainability is one of the cornerstones of FP and far more valued than in other communities. Let's look at a simple example. We explicitly state that the list should be not empty. It's in the function's interface, not in the comment or assumed in the function's body. We must ensure we constructed a valid list when we call this function. Refactoring is easy. There are no wrapper frameworks or inflexible design patterns. We don't have to worry about the global state or assumptions. Refactoring is cheap in Haskell, so you don't need to get things right the first time. And you don't have to be afraid of changing your code base. We also love composability. When you have small, independent, and composable pieces, reasoning about them is more straightforward. It lets us develop them in isolation while simultaneously building larger components from smaller ones. And the best part, we don't have to suffer pursuing maintainability and robustness when we have powerful tools. Most of the FP languages and libraries are quite expressive. This is my favorite example from work experience. We had some data transformation pipeline which accepted warehouses with stocks, and our task was to update all existing shoe stocks. So at some point, the requirements changed and the input data was remodeled. The actual details and code don't matter, don't stress over it. I'll cover this in detail somewhere else in the future. There was some list with warehouses or with inventories. This inventory field was optional, name and stock were also optional. And then at some point, the warehouses field of this response became also optional. And now we had inventories per warehouse. So it's not one inventory, it's multiple inventories. And the changes in our code were quite minimal because we were using flexible tools. So in this case, we just had to add an extra adjust and change inventory to inventories. This is it. The changes on the other side of the contract were way bigger. That's why FP languages are fantastic for prototyping. It's an industry standard that most prototypes go to production, in which case we are safe and ready to go. Otherwise, adapting the code to catch up with changing requirements is fast. Unfortunately, there is another side of this coin, which is over-abstraction. Let's revisit optics as an example. Here we have two different types to represent lens. Both of them are very expressive types, but also they're painful to work with, especially as a beginner. It's not easy to grok, and errors are not friendly at all, as the types suggest. Another example is Scala's HTTP4S, where HTTP routes is just an alias for Clysely, which sounds cool. Well, as cool as taking a nice bath. It's too much. I just want to send a couple of JSONs over the wire. And there are dozens of examples like this, and it can be very frustrating. Sometimes expressiveness leads to simplicity, but sometimes it leads to complexity. We'll talk about this later. Last, but my least favorite core value, perfectionism, which, for example, can come from obsession with robustness or over pursuing expressiveness. Scala, not expressive enough. Haskell, not expressive enough. Dependent types, not enough, and so on and on. This can be discouraging, especially in the work environment. Perfectionism is stressful, expensive, and counterproductive. While dreaming of perfection, we end up with nothing instead of having something good or great. Some FP devs would rather spend weeks re-implementing libraries and use or adapt an imperfect existing one. Others would start working on the compiler, existing or a new one, just because the feature is quirky. And then people burn out, because it's a lot of work and pressure. But it's not all that bad. I'm really grateful I can use the polished software if it ever gets published. Many libraries widely used in production have been stuck on version 0 something for years, because authors think that the API is not perfect, which I guess is a compromise.
What can be done with Java can be done with Go and can be done with Haskell. You don't have to do FP. It's not ultimately better or anything like that, because nothing is. If the person goes out of their way trying to convince you that X is better than Y, they're probably biased. It has something to do with what they deeply care about. Like, if you ever seen companies doing rewrites, you'll probably notice that the reasons are rarely purely technical. Is it politics or is it values related?
Why do anything? Just for the money? For financial stability or job security? Then the rest doesn't matter. Pick the most mainstream top-ranked tech and call it a day. Nobody ever got fired for choosing IBM, right? Or is there more to it? Intellectual challenge, growth, community, innovation, sustainability? What's in it for you?
When I started programming, it was fun. It fulfilled my curiosity and creativity. And it still does. But at some point, it became less romantic. Now I have ceremonies, Jira, eye roll in meetings, wobbly requirements, and so forth. So when I get my little moment to code, I have no patience for archaic design patterns, silly bugs, semicolons, null pointer exceptions, and other nonsense.
Let's go through some values that a developer might expect, but probably won't get from FP, because they clash with the core values or just low on the priority list. The first one is evident based on the popularity and state of FP. There is minimal effort put into marketing and growth. You might have heard of Haskell motto, avoid success at all costs. We don't want to sacrifice robustness, perfectionism, and the ability to innovate, the curiosity. Mainstream approval does not worth it. And it seems like most devs don't mind. Small is beautiful. Well, till you have to look for another job. In some sense, growth is linked to beginner-friendliness or approachability. It's hard to grow if the onboarding experience is challenging. For example, little or no documentation and learning materials, or general complexity of things. Just recall what we talked about in the expressiveness chapter. Of course, we want more users, but if the choice is between making something approachable or more abstract, for example, the cool abstraction always wins. Also, some say it's not an option to diminish the language library to make things easier for new users. I think it's just excuses. There are no technical sacrifices here, just time and effort. Plenty of languages and technologies manage to be quite friendly to beginners on top of their more technical values. I just hope the situation gets better sooner than later. As I alluded to earlier, sometimes simplicity gets a hit. This value is still up for debate. Occasionally, there are initiatives to commit to simplicity, for example, simple Haskell or boring Haskell movements, but they have yet to stick around. Again, notice how it conflicts with the current core values. For instance, it's hard to predict where curiosity will lead you. And it's hard to resist weird abstractions, quirky and maintained libraries, and experiment compiler extensions. The language, tools, and libraries have a lot of complexity. When we use abstractions, we hide some complexity, making it easier to use. But easy isn't simple. Complexity is still there, just hidden. The simplest code is no code, because code is a liability, but this fact is generally neglected. I think it's fun to write functional code, so YOLO. Another disputed value in FP is stability. Haskell and Scala have their roots in academia, so innovation is crucial to them. On one hand, they don't want to restrict the research possibilities for the sake of corporate users who wish for stability and no breaking changes. Every year, State of Haskell survey results show that upgrading the Haskell compiler breaks a significant amount of code, and people would rather stay on older versions. And it's a similar situation in Scala. Scala 3 has been around for years, but still a lot of companies stay in Scala 2 because of the breaking changes. The migration is out of reach for some. But somehow, on the other hand, standard libraries, for example Haskell's base, are too stable. They are full of unsafe and slow functions that developers should generally avoid. So why do we keep them? Because we're afraid to break all the learning materials that relied on it? Well, I don't know. How many books are there anyways? Last and the least, let's talk about debugging. The funny thing about debugging ergonomics is it's not that FP devs don't debug or like to suffer doing it, it's just not something we do that often. Once more, it's all tied to the core values. The more time you spend on robustness and perfecting your code, the less time you have to waste debugging. And if we need to find a bug, we have other tools and approaches. Functional code is composable. We don't need a real debugger. We can inspect code snippets in isolation. I love this quote from Ben Dean that I took from another article called I Do Not Use a Debugger, which says the principal problem with debugging is that it doesn't scale. In order to catch bugs, we often need to be able to run with sufficient large and representative datasets. When we are at this point, the debugger is usually a crude tool to use. Using the debugger does not scale. Types and tools and tests do. And before we wrap this up, I want to reemphasize that these values are not some noble truths. Let's look at a few examples of where the values that we talked about does not really apply. For example, Elm has a different view on this, emphasizing beginner-friendliness and simplicity. This works well for their specific use cases. At the same time, it's limiting and comes at the cost of expressiveness and curiosity, which irritates a big group of FP devs. Just ask what they think about calling an effectful JS function out of Elm. I'm also not sure about perfectionism and stability. The compiler hasn't had a release since 2019, and Elm devs are quite content with this, which might mean that it's been stable for years. I don't know, I don't have enough knowledge here. Rust is another ecosystem that strives to be beginner-friendly. Note that Rust isn't really an FP language, but FP devs gravitate towards it, and you might guess why based on the values. And it doesn't actually matter if you think that Rust is beginner-friendly or not. What matters is that they focus and prioritize it. Most libraries come with a book, and the over-abstraction is not endorsed. For example, instead of having one expressive concept to deal with optionality, errors, lists, async await, and so on, Rust has different constructs for each. It's annoying for some FP devs, but great for beginners. And I don't have to tell you about Rust growth. The hype train is blazing. You gotta be living under a pile of rocks if you have not heard of it. On top of robustness, the community aims to get shit done. There is no unhealthy perfectionism we've talked about. I love it. There are production-ready libraries for everything. But because robustness is so much valued, maintainability suffers. I might be biased, but I've also heard it from more than one Rust dev. When you start working on a feature, if you pick a wrong approach, it's pretty penalizing to go back and change anything down the road. Like changing ownership and lifetime in one place bubbles up through all the usage. Sometimes you can't even swap two seemingly innocent lines because they have to be in specific order to satisfy the borrow checker. The work that we do and the technologies that we use reflect our values.
And as you might notice, you can't have them all. If you have not done it recently, I encourage you to re-examine your values. What are your values? And does your work align with your values? And if you're doing FP, what do you think about its values? Am I missing something? I'd like to hear other perspectives. Tune in next time when I reevaluate my setup.